Okay, now we're going to illustrate the principle behind the generator and the motor. This is very important principle in electricity and very good usefulness to create energy. So you're going to see over here, we basically have the motor or a generator here, which is basically like a coil and a magnet. And we have it connected to a circuit. We have an external resistor here. We've set the external resistor to 100 ohms. We could change that if we want. Then we have an ammeter in the circuit because we want to measure how much current we're generating. And we have a voltmeter placed across the resistor because we want to measure how much voltage we are getting from the resistor. So if I place a certain amount of weight over here, so what's the physics of this is that I'm using gravitational energy, and as it's falling gravitational energy through the magnet and the coil that's here, gravitational energy is converting to electrical energy, and we're getting current in an external circuit, and we could use the gravitational energy as a way of creating electrical current. As its speed increases, the voltage reading and the current reading is going to increase. So we're going to see just before it hits the ground what they are, and we'll see from that what we can do. So as it's falling here, okay. Okay, now we're going to run it again. So if you can zoom in on the voltage and the current. Okay, now I have 20 grams. So if there's more weight, there should be more current and voltage. So if you zoom in, you should see that the numbers are getting even bigger. So 20 grams, here we go. Okay. Okay, so you should be able to create more voltage and more current. Now the opposite of this is that I can hang a weight on the bottom, and I could use an external source of electricity. So let's keep the weight here on the bottom here. So now I have it connected, and I notice first nothing is happening, okay? So it's just resting there, and you wonder, okay, what's going on? It's not lifting or what? But you have to realize we're trying to lift something that has a certain amount of weight, right? So So perhaps I need more power, I need more current, I need more voltage. So you come over here, and my original resistance, if you can zoom in, my original resistance where I ran the generator, it was 100. So I'm going to reduce the original resistance. I'm going to raise the 20 here, lower the resistance. So now the current should go up. Now I have a current of 124 milliamps, 4 volts. So my power supply is giving me 4 volts. There's more current, therefore there's more power. Power is the product of the voltage and the current. So now I can increase the voltage even more. So now 5 volts. Okay. I could decrease the resistance if I want even more. I can increase the voltage. We have it now set to resistance of 10. It's still not really increasing. Okay, we have it 4 volts here. I'm now going to increase it to go down to, okay, now you can see it went up. So with a resistance of about, let me set it to a resistance of about, let's shut this down. Make it about 8 ohms, okay? Lower the voltage, because I want to go a little slow here. Okay, maybe increase the voltage a little bit more. You can see it going up. So now we have used this mechanism as a motor. We have an external power supply supplying electrical energy to convert to mechanical. Now if I have a bigger weight, let's turn this off again. Okay, now I'm going to put the 20 grams. Now turn it on, and of course nothing should happen because you're heavier. It's not lifting. So I'm going to increase my voltage, and you can see it easily went up. So you can see this is a great tool to either use electrical energy to convert to mechanical, or from mechanical back to electrical. This is called a motor. The previous one is a generator. Thank you.